So dear students, welcome to the online classes of chemistry. So today we will discuss the remaining part, that is racemic mixture. So let us see this. What is racemic mixture? So here look at what is the racemic mixture. So it is nothing but the equimolar mixture of D and L isomers. The equimolar mixture of D and L isomers. Look here, the equimolar mixture of D and L isomers. D and L isomers. D means dextro and L means that is deo. Means it is nothing but, look here, 50% dextro plus 50% Leo. So the equimolar mixture of D and L isomer are called racemic mixture. It is called as a racemic mixture. And the racemic mixtures are optically inactive. Racemic mixtures are optically inactive. It is due to the external compensation. It is due to the external compensation. So it is due to the external compensation. External compensation means that is the optical rotation due to the D isomer is cancelled by the optical rotation due to the L isomer. That is, these are having zero optical. So it is, there is no optical rotation. So it is optically inactive. Look here, students. The equimolar mixture of D and L isomer are called a racemic mixture. And here the racemic mixtures are optically inactive. It is due to the external compensation. So it is due to the external compensation. So that is the optical rotation due to the D isomer is cancelled by the optical rotation due to the L isomer. So this shows the zero optical rotation. So it is zero optical rotation. So here such compounds are called as racemic mixture. And then what is racemization? What is racemization? What is racemization? Here you will do that is compensation. S-A-P-I-O-N, compensation. So it is compensation. So it is here. What is racemization? So it is, what is racemization? So it is the process of conversion of enantiomers. The process of conversion of enantiomers into a racemic mixture is called racemization. Look here. So it is racemic mixture is optically inactive. It is due to the external compensation. That is That is, the optical rotation due to the d isomer is cancelled by the optical rotation due to the L isomer. So it is these isomer cancels their optical rotation. For example, that is, if that is the d isomer shows right hand side, that is d isomer shows right hand side, that is rotation, and then that is L shows that is left hand side rotation, and here these that is two cancels each other and it remains as it is. So this is called as that is the reciproc picture. It does not show any rotation. The rotations of one isomer cancelled by the rotation of another isomer. And then resmization, the process of conversion of enantiomers into reciproc picture is called resmization. So here the next one is retention. Then second, what is retention? So the configuration or structure of the compound, if it remains as it is in the reactant state or in the product state, then it is called as retention. So retention is the, so it is here, retention is the structure or it is the configuration you can say. So therefore, here remember, so it is the retention of configuration is the preservation of spatial arrangement of asymmetric carbon center. Look here students, so it is the retention of configuration is the preservation of spatial arrangement of asymmetric carbon center. So it is here the retention of configuration is the preservation of spatial arrangement of asymmetric carbon center during the chemical reaction. During the or transformations during the, that is here that is during the chemical reaction or transformations. So you may also write like this: the retention of configuration is the preservation of spatial element of asymmetric carbon or preservation of spatial element of bonds of asymmetric carbon. You can write that is bonds also. Bonds of asymmetric carbon center during the chemical reaction or transformation. So it is called as a retention of configuration. Here I will give an example. That is here I will write CH3, C, CH2, OH. It is H. It is CH2, CH3. Look at this. So it is here. It is called as it is 1, 2, 3, 4, 2 methyl butane 1R. 2 methyl butane 1R. So when it is treated with hydrochloric acid, so it forms H2O plus that is here HC CH2 Cl. It is CH3 CH2 CH3 as it is called as 1 2 3 4. So it is 1 that is chloro, 1 chloro, 2 methyl butane. Look here. Look the structure. Look here. So here that is it is 2 methyl, 1 butane, 1 R butane, 2 there is 1 butane, and here when it is treated with HCl, water is removed and it forms here. So that is there is no change in the bond. Bonds are not broken. So the configuration remains as it is. the configuration remains as it is. Hence it is called as retention of configuration. So it is retention of configuration. So here it remains as the bonds are remaining as it is. That's why it is called as retention of configuration is the preservation of spatial element of bonds of an asymmetric carbon, means that is chiral carbon atom. All the different atoms are attached to this. And here it is, here, look here, so it is the configuration remains same. The bonds are remain same. But students, here the sign of optical rotation is different. Here it has it is a negative sign, it is leorotatory. Leorotatory, it has it is positive sign, it is called as dextrorotatory. Remember what I said? Here, look here, here it is the bonds are not broken. The configuration of reactant and product remains same. The bonds are not broken. The configuration of this reactant and product remains same. Means that it has that is retention of configuration. The configuration remains as it is. But the sign of optical rotation is changed. The sign of optical rotation here, the reactant is having negative sign and the product is having a positive sign. So therefore, here you may also write like this, that is the here that is the bonds are not broken. The bonds are not disturbed. So it is bonds are not broken. The reactant and the product has same general configuration. General configuration. Hence it is called. Hence it is called retention of configuration. Look here. Hence it is called as a retention of configuration. But here the sign may change. It is a negative sign, it is leorotatory, and it has a positive sign, it is dextrorotatory. You may write or may not write, then it is more than enough. So here that is, here the sign that is sign of optical rotation changes. One of it is leorotatory and the other dextrorotatory. So students, here it is about the retention and then retention after this configuration. So here it is an example and then it is regarding this explanation. So let us see this next one. Look here. The next one. Inversion, retention, and respiration. Inversion, retention, and respiration. Look here. Here inversion, retention, respiration. Both three that is comes out here. So here in this that is form. So there are three outcomes. Look here, there are three outcomes for any action: as an asymmetric carbon center. Look here, as an asymmetric carbon center. So there are three outcomes in the reaction. As an asymmetric carbon center, having the reason three forms. Consider the replacement of group X by Y in the following reaction. Look here, students. Here it is. You have to study carefully: inversion, retention, and respiration. There are three outcomes in the reaction as an asymmetric carbon center having these three forms. So consider the replacement of a group X by Y in the following reaction. I will do one reaction here. So it is, I will write this one, that is, look here, it is C3H5, C, it is H, CH3, I will write here Y, or I will write here that is X. Look here. And here, if this compound is treated with Y, this compound is treated with Y, and if it use the same, that is C2H5, then it is C, it is H, CH3, and then that is Y. Look here, here it is same to same. It is called as A, it is obtained by retention. Look at the X is, that is the replacer by this Y. X is replaced by Y and the configuration remains as it is. It is called as retention. And if again here, if the configuration changes, C2H5, C, then it is H, CH3, and it is Y. So it is Y. So look here, it is called as inversion. It is called as inversion. It is B. It is A. A is obtained, that is by the retention, and B has that is inversion of configuration. And suppose if these two A and B, if these two A and B, A plus B, if these two, that is A plus B combines, this A plus B combines, it gives a reciprocal mixture. A reciprocal mixture, which is, that is optically inactive. Which is optically inactive. So look here, you may write an example of that is, you may write an example of this, that is tartaric acid. You may write an example of tartaric acid. So here COOH, OH, H, and then it is H, OH, COOH. It is D-lactic acid, and then that is, here it is, if you write that is COOH, and then that is OH, H, C, H, OH, COOH, and then that is, it is called as it is D and L. And if these two are mixed, then you get that is like this reciprocal mixture. So it is COOH, C, OH, H, C, OH, H, C, that is OOH. It has a plane of symmetry. So therefore, it is about that is inversion, retention, and then that is this resmylation. So it is here, this product is obtained. Here that is the Y is in the same position of this X. It is called as retention. And here this Y is in the opposite direction. So Y, the X is replaced in the opposite direction. It is called as inversion. And when both A and B, the 50% of this A and 50% of B are mixed, then it will be resmylation. So here it is about this retention, and then there is this inversion and resmylation. Then the next one is stereochemical aspects of SN1 reaction. You are very familiar about this because in the mechanism of nucleophilic substitution reaction, as I already explained. Once again, that you have to study a stereochemical aspect of SN1 reaction. So it is, and immediately that is you must study first, that is you will go for SN2 also. So it is regularly that is SN1 and then that is SN2. You must study any one. So it is, then what is SN1? That is stereochemical aspect of SN1 reaction. Look here, it is substitution nucleophilic first order reaction. Substitution nucleophilic then first order reaction. So what happens here? So in SN1 reaction, here the product formed has it is reciproc mixture. Then why it forms a reciproc mixture? Why it forms a reciproc mixture? Because look here, I will give an example here. Look here. It is 2-bromobutene. 2-bromobutene. Otherwise, there is another line like this, that is 2-bromobutene. I will write the example like this. C2H5. 2-bromobutene. When this 2-bromobutene is treated with a nucleophile OH minus, or that is this 2-bromobutene undergoes slow ionization. It undergoes slow ionization. It undergoes slow ionization, forming CH3, C2H5. It is carbocation is formed, plus that is Br minus. Look here, students. It is carbocation. So it is here it forms that is a carbocation. It undergoes slow ionization. And then it is step 1. And in step 2, C, it is H, CH3, C2H5, carbocation. Look here, students. The OH minus nucleophile may attack from this side or it may attack from this side. Because it is a planar. It is a planar and it is sp2 hybridized, so therefore it may attack from any place. So therefore it forms it is two products. I will write here two products. Look here, if it attacks here, then it forms CH3, H, C2H5, it is OH, and then that is another one I will write C, CH3, and then it is H, C2H5, and it is OH. Look here. So both that is or that is gives that is a reciproc mixture. It is an example here. It is an example here. For that is both that is numerator is this. Here that is one. There is one product and it is another. So both that is into 50-50 is there. Then it is called as a reciproc mixture. Is clear? So look here, stereochemical aspect of SN1 reaction. I have taken example 2-bromobutane and here it undergoes slow ionization, forming carbocation which is planar and it is sp2 hybridized, and OH minus nucleophile, it attacks to this end or it attacks from this end or it attacks from this end because planar. And then it forms these two products. It is called as a reciproc mixture in the D and L isomer. It gives both the D and L isomer. D isomer and it is called as a L isomer. So it is a D isomer, it is a L isomer. So it is called as a reciproc mixture. So it is called as stereochemical aspect of SN1 reaction. So here for this that is you may also write that is here that is in SN1 reaction it gives racemic mixture. It gives racemic mixture because the nucleophile OH minus attacks from either side of the carbocation. Hence, it forms a racemic mixture. This is about the racemic mixture. In Islampur reaction, it uses racemic mixture because the nucleophile OH minus attacks from either side of the carbocation, hence it forms a racemic mixture. Why it attacks from either side? Because it is a planar. So it is about Islampur reaction. Now let us see this. What about the SN2? Look here. SN2. Substitution nucleophilic bimolecular reaction. So here, in this section, I will write an example of this 2-bromo-octane. Look here, students. 2-bromo-octane, CS3, C, Br, H, C6, H13. It is called as 2-bromo-octane. 6, 7, 8. 2-bromo-octane. So when this 2-bromo-octane is treated with a nucleophile, the nucleophile exactly attacks the nucleophile OH minus attacks this carbon from the side opposite to the leaving group. This is called as leaving group. This bromine is called as a leaving group, exactly opposite to this leaving group. So therefore, here the reaction takes place in only one step. So it is first, that is here the transition state also takes place. I will write directly. So it is here it forms the product OH, C, CH3, H, C6H, 13. So this is called as 2-bromo. That is here 2-bromo-octane. It is called as octane 2-ol. Octane 2-ol. So therefore, here it is called as octane 2-ol. It is called as inversion of configuration. Inversion of configuration. So it is because here the nucleophile OH minus attacks the carbon from the side opposite to the leaving group, that is bromide ion opposite to the leaving group, forming a product having inversion of configuration. So it is similar, that is if you go with your umbrella, if you caught by a strong wind, the umbrella is inside and comes outside. So it is similar. So it is here, it is called as inversion of configuration. So it is the nucleophile OH minus attacks the carbon from the side opposite to the leaving group, formed a product, that is leaving group, formed a product that is having inversion of configuration. So it is leaving group. Here it is carbon from the side opposite to the leaving group, form a product having inversion of configuration. So students, here I have completed all those things. Only that is the last that is unit is left, that is called as polyhalogen compounds. So, thank you.